Hello, young scientists. Today we're going to explore the fascinating world of natural indicators, focusing on litmus, a colorful dye that's been used for centuries to test whether a substance is acidic or basic. Imagine you have a magical strip of paper that can tell you the secret nature of any liquid it touches. That's exactly what litmus paper does, and the magic starts with beautiful organisms called lichens, as shown in Figure 4.1a on your screen. Lichens, a fantastic partnership between fungi and algae, produce a purple dye we call litmus. This litmus dye is then made into red and blue papers, seen in Figure 4.1b, which change colors depending on what they touch. Think of litmus paper as a scientific detective, revealing the hidden nature of substances. Acids make blue litmus turn red, and bases make red litmus turn blue. Before we dive deeper, think about this. Why do you think these color changes happen? Pause for 20 seconds and let your imagination flow. Now that you've had time to think, I hope you predicted that molecules in acids and bases cause this color shift by interacting differently with the dye. Let's continue our exciting journey. Welcome back. Let's talk more about litmus and how it behaves in different solutions. Pure litmus in distilled water shows us its natural color, a lovely mauve or purple shade. This is like its neutral face before the test begins. Now picture this. When we dip this litmus into something sour like lemon juice, which is acidic, the litmus eagerly changes to a bright red. On the other hand, when exposed to a basic or alkaline solution such as soap water, it turns a clear blue. This color-changing magic makes litmus an extremely useful tool in labs and schools worldwide. You often find it in the form of thin strips called litmus paper, usually either red or blue, as shown in Figure 4.1b. Red litmus paper acts like a detective looking for bases. If it finds one, it turns blue. Blue litmus looks for acids, turning red if it finds any. Isn't it amazing how something so simple can reveal the hidden secrets of a solution? Now think about your kitchen. What items could you test using litmus paper? Pause for 15 seconds and try to imagine which common substances might be acidic or basic. Fantastic. You're already thinking like a chemist. Now, it's your turn to experiment with litmus paper through Activity 4.1. Imagine you are a detective uncovering mysteries in the liquids around you. Start by mixing some lemon juice with water in a plastic cup. This creates a test solution. Carefully place a drop of this solution onto a strip of red litmus paper and observe what happens. Then try the same with blue litmus paper. Does the color change? Record your observations diligently. Then take this experiment further by testing other everyday items such as tap water, detergent solutions, aerated drinks, soaps, shampoos, and more. The list is endless. Remember, red litmus paper turning blue indicates a basic solution, while blue litmus turning red indicates acidity. For example, lemon juice being acidic should turn blue litmus paper red, but not affect red litmus paper. This helps us classify substances as acidic, basic, or neutral. By doing this, you're developing the hands-on skills of a chemist, observing, recording, and making inferences. Take your time with each test and have fun exploring the hidden world of acids and bases at home. After conducting your experiments, the next step is to carefully record your observations in a structured manner. Table 4.2 on your screen provides a perfect layout to organize your data by listing each test solution along with the effects observed on red and blue litmus papers. And finally, your inference about the solution's nature. For example, if red litmus paper remains unchanged but blue litmus paper turns red, you correctly infer the substance is acidic. Conversely, If red litmus turns blue and blue litmus stays the same, the solution is basic. If there's no color change on either paper, the solution is neutral, meaning it is neither acidic nor basic. This careful recording and interpretation help you build scientific thinking and clear understanding. As you see in Table 4.2, the layout organizes the results, so even complex information becomes easy to analyze. Now, pause for 20 seconds and reflect. How does documenting your observations in a table help you with scientific reasoning? Great thinking. Writing down observations ensures clarity and allows comparison, helping you draw accurate conclusions just like scientists do. Let's now understand an interesting category of solutions: neutral solutions. These are special because when you dip either red or blue litmus paper in them, there is no color change. No red becomes blue, and no blue becomes red. Neutral solutions have a pH value exactly equal to 7, which means they are perfectly balanced and neither acidic nor basic. Think about pure water you drink, or common salt dissolved in water. These usually fall under neutral solutions. Why is this neutrality important? Well, neutral solutions are often safe and gentle, making them ideal for life and daily use. Imagine if your drinking water were acidic or basic. It could harm your health. So, litmus tests help ensure safety too. Pause now for 15 seconds and think. What do you think happens if a neutral solution is mixed with an acid or base? I hope you thought about how it might become acidic or basic depending on what it's mixed with, showing the dynamic nature of chemistry around us. Let's see natural indicators come to life. Figure 4.2 shows 3 enthusiastic students conducting litmus tests to discover if a solution is acidic or basic. Notice the close-up of the litmus paper showing a vivid red color. This tells us the solution they tested is acidic. But what's happening on a molecular level? Acids release hydrogen ions, represented as H+ in the solution. These hydrogen ions interact with the dye molecules in blue litmus paper, causing the color to change from blue to red. Conversely, bases or alkalis release hydroxide ions, OH-. When red litmus paper meets these ions, it turns blue. This interaction is a beautiful example of chemistry's color language. Imagine the litmus paper as a canvas and acids or bases as artists coloring it differently. Can you think about why different ions cause different color changes? Pause for 20 seconds and imagine the molecular dance happening beneath the colors. Amazing, isn't it? This simple test helps scientists and students worldwide quickly classify substances, a powerful tool derived from nature itself. Now we'll explore the science behind the colorful magic of litmus. When acids dissolve in water, they release hydrogen ions, denoted as H+, increasing their concentration. Bases or alkalis release hydroxide ions, OH-. These ions are tiny chemical messengers that react with the litmus dye molecules. Let's look at the first chemical process. Blue litmus paper meets hydrogen ions. The chemical reaction causes the litmus dye to change its structure, shifting its color from blue to red. The second process in red litmus paper reacting with hydroxide ions. This reaction flips the color from red to blue. It's remarkable how the dye molecules act like sensitive detectors, revealing which ions are present. It's like a secret conversation between chemicals told through colors. Try to think about how different dyes used in chemistry might detect other ions, just like litmus detects acids and bases. This colorful chemistry connects us to the microscopic world hidden around us every day. Let's bring our science experiment into your home. Litmus paper isn't just for laboratories. You can use it to test the liquids around you to see if they are acidic, basic, or neutral. For example, lemon juice, vinegar, and aerated drinks tend to be acidic. You'll observe that blue litmus paper turns red when dipped into these, a clear sign of acidity. On the flip side, cleaning products like soap solutions, baking soda solution, and washing soda solution are basic. Red litmus paper dipped into these will turn blue, signaling alkali presence. This means that litmus tests not only teach us science, but they also help us understand the household products we use daily. Remember, knowing the pH nature of substances helps us use them safely, which is why this simple test is so valuable. Now imagine testing your shampoo or milk of magnesia with litmus paper. What do you predict will happen? Pause for 20 seconds and make your best guess. Excellent. You are becoming a keen observer of chemistry in everyday life. Did you know that litmus tests have real-world impact far beyond the classroom? In medicine, doctors test bodily fluids to check if they are too acidic or basic, which can indicate health issues. Farmers test soil pH to grow crops that thrive in specific acidity or alkalinity conditions. Environmental experts test water bodies to ensure safe drinking water and protect aquatic life. These tests often start with simple litmus paper to get quick preliminary results before using advanced instruments. Imagine how powerful it is to have such a simple tool that provides immediate information about a solution's nature, helping experts make important decisions. So, the next time you see litmus paper in a chemistry lab or health clinic, remember it's part of a worldwide effort to keep us healthy and safe. Pause for 15 seconds and think. How would life be different without such simple scientific tools? Let's wrap up what we've discovered about litmus indicators. Litmus, a marvelous natural dye obtained from lichens, acts as a color-changing pH detective. We learned that red litmus paper is sensitive to bases. It turns blue when it encounters an alkaline substance. Blue litmus paper reacts to acids by turning red. When neither paper changes color, the solution is neutral. This simple test provides quick, reliable information about the acidity or alkalinity of various substances, from lemon juice and soaps to water and salts. Understanding litmus tests builds the foundation of many science fields and helps us better interact with the chemical world. I hope you feel inspired by how nature's own dyes help us reveal hidden chemical secrets around us. Let's put your newfound knowledge to the test. Imagine you have 4 test solutions: vinegar, milk, soap solution, and distilled water. Now picture dipping red and blue litmus papers separately into each solution. What color changes do you expect to see? Will the red litmus paper turn blue, or will the blue litmus paper turn red? Pause for 30 seconds to make your predictions and write them down if you can. 30-second pause. Great job thinking that through. Here's the answer. Vinegar is acidic, so blue litmus paper will turn red, and red litmus stays red. Milk is slightly acidic, or close to neutral, so blue litmus paper might show a slight red tint, and red litmus paper stays red. Soap solution is basic, meaning red litmus paper will turn blue, and blue litmus stays blue. Distilled water is neutral, so no color change happens on either litmus paper. Well done! This exercise is a practical way to understand acid-base indicators. While litmus is the most popular natural indicator, did you know that several other plants can help detect acidity or basicity? Turmeric, for instance, turns red in the presence of bases, but remains yellow in acidic and neutral conditions. Beetroot juice can also change color when mixed with acidic or basic solutions. Red cabbage juice is quite versatile, showing different shades of color across a wide pH range, from red in acids to greenish yellow in bases. Imagine how fun it would be to try these natural indicators at home. Using different indicators helps build a richer understanding of how pH works in everyday items. This diversity of natural dyes reminds us of the chemical wonders in nature, waiting to be explored by curious minds like yours. Congratulations on completing your journey through natural indicators and litmus tests. Mastering this simple yet powerful method opens the door to exciting branches of chemistry. As you advance, you'll explore the pH scale in greater detail and learn how to measure acidity and alkalinity with precision. Remember, science is all about curiosity, observing the world carefully, performing experiments confidently, and asking thoughtful questions. Keep that spirit alive. Whenever you see a colorful change or a chemical reaction, think about the molecules invisible to your eyes working behind the scenes. Who knows? Your next experiment might lead to a new discovery that changes how we understand the world. Stay curious, keep experimenting, and enjoy the incredible adventure of science.